So here we'll check out the last piece of number 2 from the 2014 AB exam. And in part C here, they tell you that the vertical line x equals k divides the region R into two regions with equal areas. So you can kind of come over to the graph here and you can kind of envision where this vertical line is going to be. So that vertical line, x equals k, divides the region into two so that the area over here equals the area that's to the right. This is right but did not solve an equation involving an integral expression whose solution gives the value of k. Well, what we're going to need to know here first is we're going to need to know the area of the region R. And then we're going to cut that in half and we should be able to piece together the rest from there. So if I backtrack and I get rid of what I just sketched here a minute ago, let's focus on the region R first. What's the area of R? Well, if we take a vertical slice of region R, we should be able to label the dimensions of that slice pretty easily. The width of that slice is a tiny difference in x's. So this is going to be a delta x would be the width of that. And then the height is going to be from here down to here. And that's going to be a difference in y values. We need to take the bigger y value, which is 4, and then minus the smaller y value. The smaller y value, no matter where we draw the slice within the region, is always on the graph of f of x. So the volume of, the area of that slice would be found, or would be approximated by taking 4 minus f of x times delta x. Now that would be the area of one slice. We want to add together the areas of many to find the area of region R. So we're going to use the definite integral as a tool to add together an infinite number of these slices' areas. So we're just going to integrate this expression. The delta x is going to become a dx. Our limits of integration are going to be the x value at this intersection up to the x value at this intersection. And from the first couple pieces of this problem, that would be 0, 4, and 2.3, comma 4. And so our limits of integration will be 0 and 2.3. This is an integral that you can definitely break out the calculator in order to evaluate. And so if we wanted to evaluate this on the calculator in the math menu, we can get the function integration feature. We can type in our integrand, which is going to be 4 minus f of x. Have to be careful with your grouping symbols here. So here's f of x, so I need to get all of f of x subtracted from 4. And once I do that, I'll close that grouping symbol. I don't want to close this one yet. The next piece of this call sequence is to tell the calculator the variable of integration. And the variable of integration that I put into the calculator here was x. And then you give the calculator another comma, you tell it the lower limit of integration, you give it another comma, you tell it the upper limit of integration, you evaluate, and you have your result. So the area of R is approximately 3.2181715. I'm taking all the accuracy that the calculator provides there only because, and I've mentioned this in several other videos, you don't want to round off in the middle and then not have the right answer accurate to 3 digits beyond the decimal because you got lazy and rounded off an intermediate calculation somewhere. So this is an intermediate calculation because what we want to do is we want to figure out how to find the value k that cuts this region into two regions of equal area. So if I get rid of the sketching that I did up here and go back to something that we had done at the beginning of the video, if I put this vertical line back in place, this vertical line is x equals k. So I'd have an area over here that's exactly 1/2 of this, and I'd have an area over here that's exactly 1/2 of this. Now if I want to figure out what the value of k is, what I can do is I can say, alright, well, to find the area to the left, what I would do is I'd have a slice that has the same set of dimensions, right? The top is at y equals 4, the bottom's on f of x. I would do the integral from 0 up to k, right? This would be k comma 4, that intersection right there. So if I did the integral from 0 up to k, I would just be getting the area to the left of this dashed line that I tried to draw a minute or two ago. And so the integrand is going to be the same. I would want to know when this integral is equal to half of the area of the entire region R. And so if you were able to solve this equation, you'd have your value of k. There's actually another equation you could set up and solve in order to find it. Do a similar thing to the right of that vertical line. If you took a slice over here, which would have the same dimensions as this slice, right? The top would be right here at 4. The bottom would be on f of x. So if we did the integral from k over to 2.3 of the same exact integrand, this would give the area to the right of that dashed line, and we would not want to know when that is half of the entire area of region R. So either of these would be acceptable. It does just ask for one, I believe, right? Yeah, it says write an equation, and we don't have to solve it, but either of these would be acceptable.